Hello everyone, welcome back again to my channel. And as I've promised that we will begin with grade 10 curriculum. So we will start with the first topic, which is real numbers. But before I begin, I would like everyone to enjoy it, okay? And then it becomes very easy for you to understand the concept. But I will try my level best that I make it simplify for you and easy for you. If there is any concern, you can then write on the channel and I'll try to help you with it. So let's begin with our today's journey and with real numbers. So if I say about real numbers, this is something you'll say that real numbers are the one what you have not done it, right? But you have done something in your primary classes. So what are those numbers? So probably you will say that those numbers are maybe natural numbers. But how do you know those are natural numbers? Because it comes naturally, it starts with one. But in your kindergarten and primary classes, you know that those are counting numbers, starts with one, two, three, and so on, right? And then the journey begins. You add zero with it. So all of you try to understand here that one, two, three, and so on. These are simple numbers. But let me take you to the previous slide first. So when you add zero before it, it becomes the set of whole numbers. And then there is a need of negative numbers too. That means there are numbers before zero which are negative too. So you begin with those as well and continues. So that means you do a lot of number system. But before you reach to real numbers is just like, a family big name where everything comes in. Natural numbers, if you see natural numbers, which I was talking about, and along with zero, it becomes a set of whole numbers. And with whole numbers and negative numbers, it becomes a set of integers. So, all your whole numbers, positive numbers, including zero, and the negative numbers becomes integers. And then you study fractions. Fractions means of this form 1 by 2, 3 by 4, all these are fractions. So these are also kind of number system. They're also a part of it, right? But when you reach to grade 7, then you start with rational numbers, right? And rational numbers are also a kind of fraction. But what's the difference if I ask you that? What's the difference between rational numbers and fractions? Both looks like fraction, but fractions are always positives. Yeah. Let me take you to previous slide. So fractions are always positive. Okay. Always. You will say always 1 by 2, 3 by 4. But when it comes to rational numbers, when we talk about especially rational numbers, it's again going to my next slide again and again. But when it comes to rational numbers, they are negative too. When I say minus 1 by 2, minus 3 by 4, and then I say 3 by 4, all are positive, and my negative numbers, all are rational numbers. That means when I say here fractions are rational numbers, yes, but all rational numbers are not fractions because fractions are always positive, right? So rational numbers are those numbers which you can write in the form of P upon Q, right? P upon Q, that is what you have learned in your classes, and the denominator Q should not be equal to 0. So they are all rational numbers. But they are negative. Why? The reason being that P and Q, numerator and denominator, are integers. That's what the reason is. And fractions are always whole numbers. That's why they're all positive. So always keep in mind that's the first concept before you move higher to the real numbers, that rational numbers are negative too. And they're of the form of P by Q, like the fractions, but they're negative. But fractions are always positive. So if I say a real number is a big family name, so your rational numbers are also real numbers. Integers are also real numbers. Whole numbers are also real numbers. So all these numbers, all these numbers are All these numbers are reaching to real numbers. So when we say they are real numbers, but real numbers again divide itself into two, as rational and irrational. And in our book, always it is described as the numbers which you cannot write in the form of p upon q as the numerator upon denominator as a fraction. They are all irrational numbers, fine. They all look like that. But how these numbers look like? If they are not of this form, so how do we recognize that these are irrational numbers? So irrational numbers, when we say they look like this somewhat of these numbers look like that. It is in radical form, third form, okay, square root of 2, root 2, root 3, such kind of numbers. So there is a decimal form also of this that we will study. So these are simple numbers which you always recognize, and these are the ones which are afterwards. I hope this is clear. Again, do a quick recap. So real numbers are rational numbers and irrational numbers too. So we will focus now in both these numbers in this topic, rational and irrational. And in grade 7 and 8 and 9, you have focused a lot. And in grade 9 also, you started with irrational numbers. So we will see that how these learnings are going to link with our future learning now with in this topic. Okay, so let's begin with the next part of it. So the very important topic which you are going to study in this is your Euclid's division algorithm. And the second is this fundamental theorem of arithmetic. Looks very difficult, but it's simply easy. So when we talk about here as your division, okay, as the name suggests it actually deals with the division of two positive integers. And what is its usage? Why we are learning it? Because you're going to use it in calculating HCF of two positive integers. Understand, both of these properties, you're going to deal with the positive integers. Okay, we are not dealing with negative integers, only positive. So when you talk about Euclid division algorithm, so we will deal with the division of two numbers, positive numbers, okay, two positive integers. And where is its usage? Somebody asked me, why you're doing this in this topic? Because we are going to divide the two numbers to calculate HCF. Okay, and the next one is your fundamental theorem of arithmetic. So the first one is deals with the division, second one deals with the multiplication of two positive integers. Okay, so one is division, second one is multiplication. You will always remember. Now, what is its usage? How we are going to use it? The first, we are going to use it as fundamental theorem to prove our irrational of the numbers. Okay, so like irrationality, like root 2, root 3, we are going to prove it. Okay, and the second one, we are going to deal with the decimal expansion of rational numbers and irrational number both. Okay, you have seen only that it is of the form of p by q and irrational is root 2. So you're going to deal with the decimal expansion too. Okay, so as our topic progresses, you will learn a lot that how you're going to use it. So understand superficially now where you're going to use it. First, division algorithm into calculating HCF, and second, dealing with the multiplication of two positive integers. So let's begin with the first as fundamental. Euclid, I'll show you that how we deal with it. Okay, so before I begin with it, I want to understand what are prime numbers. Do you remember that? Yes. So this is something you must have done in your grade 4 and 5. So prime numbers are those numbers which has only two factors, one and the number itself. So prime number starts with 2, 2, 3, 5, 7, 11. All have two factors only. If you see 2, 2 and 1, 3, 3 and 1, 7, 7 and 1. Can you divide 7 by any number other than 7? No, it can be divided by 7 and by 1 only. But if I say, I take any, any other number, like suppose, for example, if I say 18, what do you say about 18? Does 18 look like a prime number? No, but why? Okay, so let's see. What are the factors of 18? How do you write it? So if I simplify for you, this one, 18 can be written as as you can use your factor tree method. It is 2 into 9, okay, 9. And again, you can further divide as 3 into 3, right? So 2 into 9 and 3 into 3. So it's actually going again and again. So here we have 18 as we can write as 2 into 3 into 3. So it has more than two factors, 2, 3, and 3. Okay. So it can be divided by 2, it can be divided by 3, it can be divided by 9, right? So it has more than two factors, and those numbers which are not prime are actually composite numbers, right? So here we go. So all the composite numbers have more than two factors. Okay. So this much is done for us. So you can recognize all the composite numbers. So here they're talking about composite numbers. So every composite number can be expressed or factorized like the way we did it as the product of primes. Okay, and this factorization is unique apart from the order in which the prime factors occur. So probably sometimes, if I say you can write like 3 square into 2, because 3 is coming 2 times, you all have done exponents, right? So apart from that, this one is right, this one, right? Or you can write like this as well. So apart from the order, so in multiplication, either you write 2 into 3 or 3 into 2, it means exactly the same thing. So 2 into 3 square. So either you say 3 raised to the power 2, 3 square into 2, or 2 into 3 square. So apart from the order, it is unique. Always we write to like to write in ascending order from smallest to biggest. So this one is preferable that you write in this order, 2 into 3 square. So this is what it means that you express it or factorize. This is called factorization process, right? So this is how it should be. So you will remember what is fundamental theorem of arithmetic. Any natural number can be expressed as a product of its prime factors. Okay, so this is one thing you have done. Now, let's see what's the coming up next thing after that. A very important formula you should know because you are going to deal with this in your exercise. So HCF into LCM is the product of the two numbers. So you will remember it. This is one formula you're going to use it. So A and B, what is A and B? So your A and B is nothing but this is your first number, okay? And B is your second number. So here, whenever you get such kind of questions, I will do one question for you. So that helps you to understand that how you're going to use this formula. HCF into LCM, which is a multiplication of HCF and LCM, you calculate. It is exactly the same thing as the product of the two numbers which are given. But you write it and you will remember it then by heart. Okay, so let's begin with that first. So I was talking to you right in the beginning that how I'm going to calculate the HCF of two numbers. Okay, so here we go. So if you see here, we have 135 and 225, and it's written Euclid's division algorithm. Now, before I begin with Euclid's division algorithm, it's a long division method, which you understand that it is exactly the same thing. So before I'm just, revising, recalling with you all. So here it is called divisor. And in the center, it is called dividend. Then you have quotient over here. And then you got remainder. Okay. So understand, this is something you have done before as well. Again, it gone to the next. So never mind. So divisor, which you are going to divide. Okay. Dividend is the one which is in the center, you're going to divide to. Okay. So divisor, dividend, and quotient remainder. So between 135 and 225, you're not going to the normal factorize it and get the HCF. This is a division algorithm. You'll remember it. So between these two numbers, which one is the smaller? I think everyone should point out that 135 is a smaller, right? Everyone agrees to it? Yes, 135 is a smaller. So how I'm going to deal with this? So I will make 135 as my divisor, and I'm going to divide 225 by 135. Okay, so this is something you have not done before. You all have done factorization method to get HCF. We will learn this. This is new. So if you got two numbers to find HCF using Euclid's division algorithm, okay, so first number you will take as a divisor, which is a smaller number between these two, and 225 will go in the center. Now use your normal division method. So the first one, it will go by 1 only. 135 times 1 is 135, because 2 times it becomes a greater number than 225, right? So what we are going to do now, we will go by 1. And then we will write 135. Okay? And then as soon as what is the next step? I have to subtract. So when I subtract, I got 90. Then this 90, which I got the remainder, I have to continue. This becomes my divisor. Okay, and this 135 will come now as a dividend. I have to use this as the dividend. So now divide it. The same method, okay? So again, 90 times 1 is 90, and 90 times 2 becomes 180, which is greater. So it will go by which number? Again, 1, okay? So again, go by 1 and then minus it, okay? As a normal division. It's a normal division. There is nothing new. The newness is that the remainder becomes divisor. That's it. Now you again subtract. You got 45. Yeah. Now, which number will go as in the center? Here, this number 90. Okay. The first previous divisor becomes your dividend. So you write it here. Now, can you divide 90 by 45? Yes, it is going completely. So 45 times 2 is your 90. And you got remainder as 0. Now I should stop. Okay. So where my remainder gets 0, that divisor is my HCF. Easy? Easy peasy lemon squeezy in your language, right? So 45 is HCF. So if you have to write the HCF of these two numbers, it's 45. So you all have to carry on with this method until you get 0 as the remainder. So understand. Let's recap again for this. So you got two numbers. So first thing, you have to select which one is the smallest number between these two. So that becomes the divisor, my first divisor. Then you divide it normally, then you get a remainder. That remainder becomes the divisor again. And your previous divisor becomes the dividend. It takes the place. And you carry on with this process till you get 0. When you get 0 as the remainder, the last divisor becomes your HCF. Okay. Now practice this 1 or 2 questions and then you will become confident in it. Okay. So let's move on to the next thing. I hope it's clear. Okay. If anything is there which you did not understand, then we will do it. So let's move on to the next one now. Now, the next kind of questions which you will see is your this one, which is very, very easy. Okay. So which is very, very easy. As I always say, Monica ma'am says it's easy, but it is. Okay. So express each number as a product of its prime factors. As I told you that each composite number can be expressed as the product of prime. So here you go. You have fundamental theorem of arithmetic. Before that, you were learning in previous slide as Euclid division algorithm. Now the next one is this. Okay. So probably if there is any change in the curriculum, then you can skip that part. And this one is there. Okay. So now this is something you are doing it from previous years. So we will go by LCM way. Okay. So 140. So we will write 140 here. And how do we do that? Okay. So first, as we always say, it will go by 2. You see your last digit, which is 0. It can go by this. And then you further divide. And then again, you go by 2 again. You get 35. Now it can go by 5 and then 7. It cannot be further divided. So how do you write this? So you write like this here. Now 2 times raised to the power 2. Why I wrote 2? Because it is coming 2 times. 2 into 2. So you all have done exponents, I believe, in grade 7 and 8. You have learned that. So I can write like 2 raised to power 2 into 3 into 5 into 7. Okay. 1 second. Let me get the eraser. I hope you understand it's 5 only. It's 5. Just that, to write 5. So 2 raised to the power 2 into 5 into 7. And similarly, all the numbers are like this. So you have to factorize it with your same method, which you were doing from many years. So this is how it is. So product of this can be expressed as the product of prime numbers. You can say 2 is a prime number, 5 is a prime number, 7 is a prime number, right? Okay, so this is one part. Now the next set of questions, what you will see. Second is, remember I told you there is a very important formula related to HCF and LCM. So we are going to use that. So second is, find the HCF and LCM of the following pair of integers and verify that LCM and HCF is product of numbers. So how we are going to verify it. So let's begin with the first set of questions, which is 26 and 91. Okay. So let's begin. So I know that how I have to do for HCF 26 and 91. Okay, I do it always together for HCF. Now both can be divisible by not by 2, not by 3. I think both can be divisible by 13, I believe. 13 times 2, 26 and 7. So 13 is that common number which can divide both 26 and 91. So this is my HCF, which is 13. And now the next part is I have to calculate LCM. Second again. Now the next I have to calculate LCM. So for 26 and 91, I have to calculate LCM and I have to go to a little long process. So first of all, I have to go by 2. So 1 times 2, then 3 to the 6. 91 can't be divisible, but both can be divisible by 13. So 13 times 1 and 13 times 7. And now I have to stop. So LCM for this is 2 into 7 into 13. Okay, so this is how it is, which on multiplication is 2 times 7, 14, 14 times 13. So it is coming as 182. Okay, so what you have to verify, you got LCM and HCF. You have to verify the product of two numbers also. So HCF into LCM, that means 13 into 182, what it gives me. So calculate here, 13 into 182, which is LCM and HCF. It is giving me as 2,366. And what about 26 and 91? And 26 and 91, multiply both. So 26 and 91 is giving me again 2,366. So did you see the product of both HCF and LCM and both the numbers is the same? So it verifies, okay? It verifies, it works. So I hope that you all are clear with this. And we will do a quick recap again. So the formula you're going to use this is a very simple and easy one. So HCF and LCM, when they ask you to verify, you calculate HCF and LCM separately, multiply both of them and multiply both the numbers together. So you will find that both of them is same. The product of both of them is same. And that's how you verify it. Okay. So it's something very easy in your first topic. Let's see the second one. So first is explain why these are composite numbers. Now, why these are composite numbers? I think it's easy. Now you understand what are composite numbers, which has more than two factors, number and it one itself. Okay, it has more than that. So let's see with our first one that how we are going to prove that it has more than that. So first of all, let's see if we can prove with the first one, 7 into 11. What is the common between 7, 11 into 13 plus 13? Can you see that? Okay, so I think 13 is coming to both. So 13 is common. Okay, so 13 into 7 into 11. 1 second. So quickly going on without clicking on the tip. So 7 into 11 is 77 and plus 1. So it is, oh, can it changed? So 13 into 78. Now you have to further factorize it. So 13 into 78. So when you factorize it, what you will get? As soon as I click and it goes like that. So 78 is 2 times 3, 6, 6 into 13. Can you see that? It has more than two factors, 2, 3, 13. Yes. So this is the reason it has more than two factors. So these are composite numbers. So you can try with the another one as well, with the second one, why these are composite numbers. Yeah. So it's actually very easy. So these are actually your first topic, real numbers, is based on the foundation, what you have done in your middle school, 6th, 7th, 8th. And it is built up on that only. So let's begin with the next question. And today this is a last, and then we will deal tomorrow with the next one, that how to prove irrational numbers and the decimal expansion, and then our topic is over. I know it's less, but you have to practice it. Okay. So now let's move on to the next question, because it also deals with LCM and SCM. Okay, read it. So there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Both are taking different time. Yeah. Suppose they both start at the same point and at the same time and go in the same direction. Okay. So now this is something very important. So whenever you have some word problem, it is very important that you highlight as soon as you get a paper. As soon as you get a paper, you highlight few things. So first, time, 18 minutes. Sonia is taking 18 minutes. And Ravi is taking 12 minutes for the same, same round, but 12 minutes. Now, they both start at the same point. They both start at the same point, same time, and both going in the same direction. After how many minutes will they meet again at the starting point? So they're asking us, how do we calculate that? After how many minutes they will meet again? So we have to catch this, that both Sonia and Ravi, they are moving in the same direction and at the same time. So what we have to do? It means that the method which we need to find to know that they're meeting at the meet again at the starting point is the LCM, least common multiple, when they will meet again, which is the least common between both. Okay, so understand here that the point is to method which we have to do and understand, that's LCM. Understand the least common multiple when they will meet again, when they start at the same point and at the same time, but they have the different timings then after, but at what time they will meet again. So that you will get only from LCM, least common multiple. And how to do that is the same method. as your LCM method, prime factorization method. Yeah. So let's begin that. Uh, where do we do? Where is the place? Okay. So 80 and 12. So first of all, it can go by 2. So 2, 9, and then it's 6. It can go again by 2, although 9 cannot be divisible, but 6 can be. Now both can be divisible by 3, 3 and 1, and then last finally with 3, 1 and 1. So, so if you see, you check what are those prime numbers you got. 2, okay. So here you got 2 into 2 into 3 into 3. So that means 2 times 2, 4, 4 times 3, 12, 12 times 3, 36. That means both of them will meet again after 36 minutes. Okay, so that's how it is. So I hope that today you are clear with that how to use Euclid's division algorithm and fundamental theorem of arithmetic, and you actually practice it. The formula to calculate the product of HCF and LCM with the numbers also, how you can verify both of them are equal. So again, I would say that you all have to understand that it is super easy, but only it will make you, as I always say, practice makes a man perfect and permanent. So it's your turn now that you actually take it, because now it's the time that you realize it. Just hold on for a minute. Okay. Okay. So I hope that you have understood today's topic and you practice it. And practice as much as you can, because in math, especially, practice makes a man perfect and permanent. And the right kind of practice will lead you permanency and perfection. So I hope that you've learned, and all the very best for the next class, and enjoy it.